So MapReduce is invented in 2008 to 11. We have used this in this period, 2008 to 2011. What we are doing in the MapReduce is we are taking disk, input source as a disk, and each and every step is performing in between disk only. Which is HDFS, Hadoop Distributed File System, disk. Each and every IO operation is taking place in between disk to disk. So each and every step here, whatever we are doing, like mapping and reducing. Mapping is nothing but where we are doing iterations, right? Each and every iteration is taking place in between in memory. And aggregation also taking place in between in memory. So in MapReduce, what we are doing, we are writing from disk to memory and in memory to disk to in memory to disk. Due to this, the process became very slow. So let me write the notes. Due to disk to disk operations, process became slow in MapReduce. Every iteration operation will be done on disk or in memory. So there is an idea, why can't we use like traditional database? Because this is a very slow process and it is taking too much time. We are having very large files. We need to do it very fast. So there is an idea behind this is so there is an idea, why can't we do like database? Why can't we do like database? Then what happened? Then the Spark came into picture. What is Spark? What is Spark? Now we have entered into our main subject. What is Spark? Spark is an in-memory distributed processing engine. Spark is an in-memory distributed processing engine. This is very important. Spark is an in-memory distributed processing engine. In 2008 to 2011, we have used MapReduce. So for MapReduce, which language we have used? We have used Java. Who used this? This is used by Yahoo, Google. It's invented by Yahoo and Google. So from 2011 onwards, from 2011 onwards, we are using Spark. So as we can see that in the 2 days before class, Spark supports Spark supports SQL, Java, R, Python. SQL, R, Java, Python, and Scala also. So these are the programming languages supported by the Spark. Now we need to understand what is the how many types of data is there. Okay, how many types of data is there? We are having three types of data. Three types of data. One is structured data. Structured data. Second one is structured data. Examples would be Excel, CSV, Excel, CSV. So the data which looks like in tabular columns. So if you see the Excel sheet, it will have the fields and records, which is nothing but columns and rows. So whatever the data you are able to see in columns and rows, that particular data is called as structured data. Second one is semi-structured data. Semi-structured data like JSON, XML code. JSON code, if you see, it is like a Python dictionary. You can see here. I'll show you. So this is a code. See here, it is not in the tabular column, but it looks like a Python dictionary. So Python dictionary looks like this. It would be key and values. One key, city is the key, and homestead is the value. Okay, review count is the key, and 5 is the value. And it can be array or it can be anything you are having. Even for categories, you are having burgers, fast food, restaurant, and all. Longitude you are having. So key value pairs, this kind of data, wherever you are looking this kind of data, it will fall into semi-structured data. Semi-structured data. JSON and XML. So third kind of data is unstructured data. Unstructured data. It would be like you are having log files in that, okay, or it may be images, it may be videos, it may be audios. This kind of data is called as unstructured data. So we are having mainly three kinds of data. One is structured data, second one is semi-structured data, third one is unstructured data. So structured data is nothing but where you are seeing in the tabular columns. You will see the data in rows and columns. Semi-structured data, you are seeing in key value pairs. Unstructured data. So all social media data. Like it will have text, and it will have videos, it is having audios, and all this kind of stuff you will see in the unstructured data. So here you need to understand a simple thing. Spark can be used for and like we are having mainly two processes, okay, two processes. One is batch load process, which is nothing but we are having historical data where we are having the DB's data or on-prem systems data. You are having all that data and you are loading that data into the target, okay. This can be used for MapReduce also works for this. MapReduce and as well as Spark, both can work on this. Spark. Second kind of process is streaming load, okay, which is a real-time data. Suppose if you are looking your cricket match, okay, we are watching the cricket match in our TVs. That is a streaming data, and you are watching live on your mobile, or you are watching live on YouTube. That is all called current data or streaming data. So it is streaming into your systems. That is nothing but streaming load. Here you can understand, whenever you are watching, those who are watching cricket, they can understand it. And suppose if you are watching here, okay, fourth over, second ball or third ball, it means that there it is already fourth over is completed. Anybody know that, like when you are watching your cricket match, so on your suppose if you are, it is there on 4.4, suppose, so it is in the stadium, it is already completed the fourth over. Why? Because streaming data is a data where it will take some data, means it will load there would be checkpoints, okay, checkpoints. So for suppose 0.3 seconds. I'm taking one example. Suppose the checkpoints, they have kept it 0.3 seconds. What it will do is the 0.3 seconds video and audio is going to be stored, and then again it is processed and it is loaded into your streaming like platforms where you are watching it. Suppose if you are watching on the Hotstar, what it will do? It will take 0.3 seconds of data and it will stream it to your devices. So it is nothing but, it is also a kind of historical data only, but very less amount that you need, very less time. It should be like that. Okay. Am I making sense? Like, have you faced that situation anywhere?
Yeah, Divya, I understand that.
Yeah,
But
you
I
can.
mean, I like a bit to Google it on the before also. As I know, like 16 seconds or something, it will delay from the match like
Yeah, those who are doing the betting, they'll know online betting.
that.
They know very, very well, because they used to place their bet depending on their streaming thing. but it is already over at some place. They are already out at that moment, but we used to bet they going to win or like that. You can see on your mobile you are having different kinds of apps. In that app you will get exact count, because that is not streaming. They were entering it manually, or it is like very speed they were doing. So due to that, actually many people are going to lose, because it is already done match, but you are betting over there. Due to this online betting, many people are they were failing to bet because of this thing only. It is you can catch the delay if you are really on the stadium and some people are watching in the TV or somewhere. That definitely gonna be some little delay would be there, because it is not the exact live match. Live match you can't find, because it has to be stored somewhere and it has to be released. So that's where you are facing all these problems. So I saw many people, those who are betting depending on their live match, but they will fail because of this only. That okay, that is fine. So you are having this checkpoints. So this checkpoint, suppose Sai is saying he is having 16 seconds delay. Means what? Here the checkpoint amount would be 16 or 15. Again, 1-2 seconds would be delay in your device. So to get that into your due to your internet or due to your bandwidth and all. So this is what the streaming data. Streaming data is nothing but real time, but it is not exactly real time, because you will having some checkpoints over there. In that checkpoint only the data is going to be loaded. Even if you Sai, if you are working in Databricks, you will have that in your if you are going through your medallion architecture, there you can see some bronze where or bronze or somewhere there would be a folder called checkpoints and schema. You can see it there. You are having that in your project site?
Oh, okay, yeah, like checkpoint I didn't hear.
No,
Schema,
no.
catalog.
Schema, catalog, that is all fine. But what is the architecture you are following over there? Medallion only, right? So you are having your landing layer, bronze layer. Am I right?
So
No, you
I
don't
mean,
have a.
I'm not sure, but I will explain within a bit. So generally, what will happen? We'll receive the file from the source in some acquire and publish layer.
Okay.
Okay. From there, it will come to the landing layer. It is
Okay.
cloud.
Yeah.
From there, we have some orchestrator, one type of file watcher job running. It will
Okay.
trigger the Databricks workflows whenever that file is received for
Okay.
loading the data into table.
Okay. Okay.
So this is the process.
This is the
That
process. Then have you ever checked into your workflow and opened it? What is going there?
yeah, yeah.
Okay. So in the workflow, what is there?
So they will write the DBT code,
Hmm.
which contains like first it will check the metadata validity in the first stage, whether
Hmm.
all the columns and data types
Yeah, yeah, that I understood.
on the file name.
Hmm.
So it will go like that, and then it will write the test cases like not nulls or unique columns, or is there any test cases. So then it will load into the views if everything goes fine. So it will go like that.
So you are using batch load there.
Okay.
So you don't know this streaming. If you are going through your streaming data, read stream, write stream would be there. Whenever
Yeah.
we are discussing Spark, PySpark code, then you can understand. But there would be one folder inside Bronze or somewhere they will take that. So inside that folder, you will have your checkpoints and schema. What happens is sometimes you will get file, okay, but that file is not loading properly into your bronze and respective related layers would be there, bronze, silver, and gold. Why? Because this schema where we have defined at the starting, it will restrict the data, because they have changed their schema. Schema is nothing but, right? They have
Yeah,
changed
yeah.
their column names, or columns are going to be changed. Due to that, it is not going to load. That thing we will discuss and we'll know. While we are writing the PySpark code, we'll enjoy it literally, because it's somewhere like it is like a play where you can do it. Okay. So one thing you need to remember here, one thing that is very important, Spark is replacement for MapReduce. Okay, Spark is replacement for MapReduce, but not for HDFS. Why? Why? Because MapReduce is, we already discussed this. We have not written here. We are having two things in big data. We have discussed that. One is where you are having storage, and second one is the
Processing.
processing. So MapReduce is nothing but a process. MapReduce is a process, but HDFS is the storage. So Spark is for the process, not for the storage. This is, many people are going to be confused. Okay, so now we are doing the we are kicking off the MapReduce. So we are using Spark and we are kicking off the HDFS also. It is not like that. HDFS is nothing but Hadoop distributed file system. Distributed file system is nothing but where we are distributing the memory. So distributing the memory is nothing but that storage part. So that storage part, the file is going to be distributed into many blocks and it is going to be stored. That is what HDF is. But whereas MapReduce is where you are doing your process, means mapping is nothing but a for loop and reduce is nothing but aggregation. So that is a process. So we are replacing MapReduce with Spark, not HDFS with Spark. Spark is also process, not the storage. So Spark is replacement for MapReduce, not for HDFS. What is MapReduce? MapReduce is nothing but analysis. HDFS is storage. So definitely there would be a distributed file system for every process. So what are the public clouds we are having? Public clouds would be Azure, AWS, Google. Azure is Azure only. Next one. AWS is nothing but Amazon Web Services. Amazon Web Services. Google is GCP. Google, yeah, I can just simply give GCP. Cloud, Google Cloud. And there is one more thing, maybe we don't use, but it is there, Alibaba. Alibaba is also a public cloud. And what are the private we are having? Many things we are having, but here private would be HP, Oracle, IBM, SAP, Snowflake, Informatica, Teradata, Salesforce. These are the private clouds. So you are having this many. Let's go into application. So this is the difference between Spark and Hadoop. We need to understand Spark architecture, but it is not possible to understand in one class. We will slowly see the programming and everything. Parallelly, we can understand the Spark architecture, how it would be. But now I'll give a high-end picture where you can understand Spark architecture. Okay, we can see it while writing the code and how the Spark behaves. We can see in the cloud, like where we are having the community edition. So I hope you have created the community edition account. So this is a Spark and this is Hadoop, where you are having the difference. You can see we are having HDFS disk. See, both is having HDFS disk. And here, because from here to here means one step it is going to take. So the process which we are taking, we are having RAM completely. You can see here, this is in between the RAM. RAM is nothing but where we are having in memory or temporary memory. So this is a temporary staging area where we are doing all the process in Spark job. Whereas coming to Hadoop job, you can see here, we are having HDFS hard disk and hard disk, hard disk, hard disk. In between, you are performing all the steps. Where you are performing exactly, you are performing on the in memory only, but you are doing all IO operations in between the hard disks. Hard disk is nothing but where you are using your ROM, read-only memory. So that is nothing but disk. Disk to disk operations are very slow. You can understand in common way also. Where if you are having one hard disk in your laptop, some drive would be there, and again you are having your pen drive or something where your CD or that is disk only, right? So if you want to write this data onto the pen drive, it is definitely taking too much time. Sometimes it is going to take, if you are having huge amount of data, it will take sometime 1 hour, 1.5 hour also to from your laptop to any pen drive to get the data inside that. Suppose if you are copying and pasting the same file in your system itself, so it will take very less time. It will do it in fraction of seconds. Suppose if I'm copying and pasting how much MB of file in my system, it will take very less time. There, if you are copying inside, if I'm copying from C drive to desktop, it will take very less time, right? Copying the file. But if you are copying the file from your disk to pen drives or CDs, it is going to be taking very much time. That is what you can understand in common way. So disk to disk operations are going to be very slow, and it is a little bit costlier because you need to use the hard disks. Whereas if you are using the RAM, before it was costly, but nowadays we have had many inventions in the RAM memory, so it became very cheap now. So you in the in memory process is going to be very fast. That's what you need to understand. And here, this is the Spark applications you are having. So you can see the Spark, and you are having Spark is used for analysis, Spark is used for machine learning, and Spark is used for ETL, like Talent, Oracle. Spark is used for streaming, and Spark is used for data lake everywhere. I can give you a small example. Just hang on. Those who have came from ECE background, they might have heard about radar technology. So radar technology where you are using to find the suppose if a vehicle is having rushing, or it is crossing its speed limit, you will see that on the highways you are having speed limit like only 60 kilometers per hour, 80 kilometers per hour, 100 kilometers per hour. It would be like that, or signboards would be there on highways or somewhere where you are driving your cars or bikes. So when anybody is there, like from ECE background, electronics and communication, those who have studied radar technologies. So in shipping also, the ships, where are the ships exactly? They were moving in which direction? Or in even in the space aircrafts also, you can see that in which direction aircraft is going, and if you are receiving the signals, it is there you are using the radar technology. Before Spark, we have studied all this. So this radar technology, what it will do is, they will send some radar rays, and the radar rays are going to be reflected back. Due to that speed and the strength of the signal, we can understand how much speed that object is going and how far it has gone. That is what the technology we are having in radar. But that entire radar technology now replaced by Spark, because even when you are moving your vehicle very speedily, they were using internally Spark technology, and they were capturing your everything, the data. Suppose what is your vehicle number and how many times you have crossed. One of my project is there, that is US based project. So in that project, actually, we are having even how speed, like some drivers would be like that, they will do the sudden brakes. Even that, how much sudden brakes he was applying and everything, it is recorded, and we are processing through the Spark. We are having that project now. Just hang on a second. I'll come back. So we are using that in our projects, and we are calculating particular drivers, how speed he was going, and how it's and how much speed he's applying his brake, and how the horn he is blowing. Like even you can see in some signboards would be there, it is a school zone area, you don't blow horn. It is a hospital area where you can't blow the horn. But it is not like that in USA. It is like that, you, if it is a rule, then you need to be follow, because I'm doing that project. So I saw it, and I was shocked, really. So it is like that, we can apply Spark on the top of it, and we can calculate everything, what's going on, and how, what is the statistics, and what such kind of a vehicle is there. So all this very huge data, it is going to be captured by the Spark. You can use it for streaming, you can use it for ETL. So as we have discussed, for ETL, we are using Azure Data Factory or Informatica, or any some of the ETL tools are there. But nowadays, we are using Spark as ETL also, and we are using Spark for data lake. Data lake where you are having Hive, okay, and see here you are having Teradata and all these things. You can see machine learning. For machine learning also, we are using Spark for graph processing, analysis. Analysis is where you are using your W, Jupyter, and even for Power BI also, who are giving the insights, it is given by the Spark. So everywhere in every project nowadays, Spark is going to be used. See, this is evaluation of Spark, how it has evaluated. First, actually, 1998, Google has published a paper, okay, and who Page and Brin, these two, they have published a paper against like Apache Spark, and this paper 2004, it became into the MapReduce paper, 2004 and 2003. So this they have discussed in the Hadoop Summit in 2008. Now in 2006, what happened? 2006, Hadoop, Yahoo has made Hadoop HDFS system as open source. Okay. So this one, and next in 2008, Hadoop Summit has happened. And in 2009, Spark, like they have started the research on Spark projects. In 2010, they have published the Spark paper. Okay. In 2010, Spark became an open source. many inventions are there outside, but why we are learning all these things is because these are open sources. Open sources is nothing but where you can access it without any cost. So it is free to everybody, available to everybody. That is open source. They made it as open source. And then after, one RDD paper is given. RDD is nothing but a data set where we are using on the top of Spark. So this is the first invention where they have used the RDD. And most RDD we are not using in our daily day-to-day work, but most of the 90 to 99% questions you will get on RDD in the interviews because RDD is the backbone. They have started in the RDD, so 90% questions you will get on the RDD. But now you are using data frames, but you will get the questions on RDD. Why you are getting on the RDD is if you understand the basic concepts of RDD, then only you are able to understand data frames. That is the main motto behind this. Even I'm an interviewer, so I know that how the interview panel is going to ask you. Okay, RDD in 2012. And then in 2013, Spark is moved to Apache Software Foundation. Okay. In 2013, Spark streaming started, streaming paper published. And in 2013, Python API is added on to the Spark. So when the Python API is application programmable interface, Python is added onto the Spark, then it became PySpark. Okay. So PySpark is nothing but we are doing the Python and SQL language coding on the top of Spark engine. That is PySpark. Okay. In 2014, Spark becomes an Apache top level project. 2014, graphics paper is released. 2015, Spark SQL paper. See here, first what you got on the Spark, it is Python. Then it is Spark SQL. Then it is transforms, tensor forms. Frame tensor is different, but okay, we are using tensor frames to connect. Okay, and this is ML library paper, machine learning. And again, 2017, it is deep learning, where combination of machine learning and deep learning is nothing but artificial intelligence. So this is the Spark evaluation. Which Spark? It is Apache Spark. So what is Spark? Spark is nothing but in-memory processing engine. Many datasets fit in memory of a cluster. Memory is fast and avoid disk IO. So main motto when we are moving into Spark is you need to remember that we are avoiding the disk operations. We are not doing any disk IO operations. We are doing everything in the in-memory process. That's why it is very fast. Spark distributed execution engine. So if anybody asks you what is Spark, Spark is an in distributed in-memory processing engine. Why it is distributed? We are performing it is on distributed file systems, which are nothing but HDFS file systems. Some other private file systems are there. Those are distributed file systems. So these are the Spark applications we have already discussed. So for machine learning, we are using Spark, and fog computing also we are using. And so what is fog computing? Fog computing is nothing but where you are having all the logs information in that. You will have like dashboards and all. So that kind of things it can come under fog computing, and it is for interactive analysis, and we are using it for machine learning as well. These are the applications of Spark. See this template. You are having data warehouse, Hadoop MapReduce, and Spark. These three things. we can see the differences. Okay. Data warehouse, where we are having separate compute and storage. When we have discussed Synapse, you might know this. So, but it won't have the separate compute and storage. Whereas Hadoop MapReduce is having the separate compute and storage. So, where you are having your own cluster, your storage and everything, it is there. Data warehouse, it's only we can use only SQL on the top of data warehouse. We don't use any other language. We don't use any other language. Those who are working on the Synapse, they can know that. So it is only SQL we are using on the data warehouse. But Hadoop is not like that. Hadoop MapReduce can use ML also. ML means different languages like Python, Scala, or different language, Java also. As we already discussed, MapReduce is working on the top of background is Java. So it is not SQL and open source at scale. So have you heard any data warehouses at open source? No. Synapse, we need to pay more. And whatever suppose I told you, like data warehouses, a Snowflake, there also you need to pay, right? These are all not open sources. But whatever Yahoo invented, Hadoop MapReduce or Spark, Apache Spark, these are open sources. SQL and optimization. Data warehouse completely works on the top of SQL only. So a querying language which we need to do the data warehousing concepts. And we can do the optimization also. But whereas in Hadoop MapReduce, it works on the Java, but it never works on the Spark SQL. So as we discussed, MapReduce is working on Java. MapReduce, we have used Java. But here, Spark, we are using SQL also. We have already seen by creating one table in the community edition. Now we are going deep dive into the community edition and from tomorrow's class, Monday onwards, tomorrow onwards, and you can see how we can perform SQL operations in the Spark also. But Hadoop, it won't support. Data warehouse completely on SQL. Data model and catalog. So data model and catalog. What is model and catalog? Where you are doing the changes in the data, or if you are finding the nulls, if you are having the junks and you are removing all that, you are applying all the aggregations, all these things will come into the data warehouse. But in Hadoop MapReduce, you can do only aggregation. You can't apply anything over there. So it is only MapReduce is nothing but only we are collecting the number of keywords and we are giving the aggregated amount. As simple as that. Only for that purpose only we are having. We discussed already that thing. And Apache Spark is for data model and catalog also. And here you are having ACID transactions. What are the ACID transactions? ACID transactions are very simple. Those are update, insert, and delete. So, update, insert, and delete. This can happen in any traditional database, right? Any traditional database, you can do the update, delete, and insert. But it is not possible in MapReduce. It is not possible in file system. It is possible in where it is possible? It is possible in the database, not in the file system. Hope you understand what is the difference between file system and database. Database is where you are having only structured data. Database is nothing but where you are having only structured data. Whereas file system is you will have three kinds of data in that. One is structured data, semi-structured data, and unstructured data. All these three kinds of data is supported by your file system. But ACID transactions is nothing but update, delete, insert is not only Insert will be supported in the file system. Inserted is nothing but what? Adding the data. The update and delete is not possible in file system. It is possible in database management system where you are updating. So, suppose I have given an example. Again, I will give it to you. Suppose we are having name, account number, okay, amount, which is current amount, credit, debit. So credit and debit. Name, suppose I'm giving Sai. Second one is Agastya. Some so and so account number. Okay. Account. You are having your amount. Suppose you are having 5 lakhs in your account. You are also having 5 lakhs. Now, what happened? We are having this information. Suppose if I'm taking Sai account here. Okay. Sai account I'm taking, and I'm not giving everything for time being. So what, suppose if I have deposited 1 lakh rupees into your account. 1 lakh rupees into your account. So when I have deposited into your account, what happened is I'm inserting some data. This is money, but for the database, what it is data. So 1 lakh rupees is credited, which means I have inserted 1 lakh rupees data. 1 lakh means this number I have inserted into the database of a bank. Now what it will do is, it will add this to this. Okay. So I have inserted data, and what it is doing, it is updating your old amount to how much? It is updating to current amount. It is 6 lakhs. What happened here? It's 5 lakhs before, now it became 6 lakhs. Why? I have inserted some data. Due to this, it is updated. This is nothing but update. This operation is nothing update. Again, what Sai did is, he withdrew or he transferred some amount to somebody else. Some 2 lakhs. Now fine. So this 2 lakhs, what happened? It is going to be deducted from your 6 lakhs, and now it became 4 lakhs. What is this operation? This also update only, right? This also update only. What happened? We are updating this amount into 6 lakhs, 4 lakhs due to this credit and debit, right? Due to this credit and debit. This is what the update. Then what is delete? I want to delete Sai's account. So what I'm doing, I'm just removing this. This is delete. This is delete. This is insert. This is delete. So this is update. This kind of operations is nothing but ACID transactions. ACID transactions. You might have heard atomicity, right? What is acid transactions, continuity, integrity, and D would be something. Why it is like that? Suppose this is your statement of your, this is your bank statement, right? So if I withdraw from my ATM, suppose I have withdrawn some 5,000 rupees, then it has to be reflected as 5,000 only. It should not be 4,000, it should not be 3,000, it should not be 1,000. Means what exact, what I did, that has to be reflected in your database. That kind of things, it is called ACID transactions, which are nothing but proper way of up, like what, update, insert, delete. These things, these three things would be prompt. That is what the ACID transactions. Why we went for that? So this is, so this transactions would be supported by Apache Spark due to Delta Lake, because Apache Spark or Hadoop MapReduce both are file systems, whereas data warehouse is not a file system where you are having database inside any data warehouse. So this is a simple way for the RDBMS systems, any data warehouse. But whereas coming to the Hadoop MapReduce and Apache Spark, these are not the database. These are file systems. File system is nothing but simply you can understand like this. See here, I'm having this many files in my system. And these files are how they were, there is a hierarchy, right? Folder structure. Inside every folder, I'm having another folder or file. See, you are seeing this, right? This is file system. So whatever, what you are watching in my screen, this is file system. This is RDBMS. This is RDBMS, Relational Database Management System. In this, I'm having what I'm having? Databases. See, this symbol is database. Adventure Works I'm opening. So inside that, what I'm having? Tables. These are all my tables. All this is structured format. See, this is in structured format. You are having data in structured format. You are having data in structured format. This is RDBMS. In RDBMS, if I want to delete, okay, if I want to delete a column from this table, is that possible? It is possible for me. What I need to write? I need to write a query for this, SQL query, delete. Yeah. Delete from where I'm writing a query, SQL query, where department ID equals to 16. I want to delete this. Maybe 16 is there. Okay. I'm just trying to execute this query. 2 rows effect. Now I'm querying this. Let's check any department. How to check this? Any department, select a star from table where same query. No data is displaying because I have already deleted it. So deletion is possible here for a particular row. I want to delete in the human resource employee department history. I want to delete something. I have deleted it. It is possible. And if I want to update something, I can update. If I want to insert something, if I want to insert some data, I can insert. This is RDBMS. This is the database management system. But whatever we are seeing here, this is file system. We can delete entire file, not a part of that, right? Suppose if I want to delete something from the departments, okay. So is that possible? No, we need to delete entire thing. So file system only allows you to insert the data. How you can allow, suppose if I want to store some data into the downloads, I can store it. I can insert the data. So it will only allow you to insert the data. It won't allow you to update a file or it won't allow you to delete a file. But it is possible now in, this is a beauty of this Delta Lake. So Delta Lake is especially designed for the ACID transactions and time travel. Due to this Delta Lake, we are able to delete, insert, and update a particular part of the file. So this is what Apache Spark. Apache Spark is a combination of warehouse and MapReduce. Both the features would be here, and one more good thing from the Apache Spark, it is a open source, which we can use. Shall I stop it now? Let me give this template just for 2 minutes. So Hadoop MapReduce and Spark. What is Hadoop MapReduce? Hadoop MapReduce is what is this? This is storage. And what is Spark? Spark is process. Yes. And MapReduce is a process. Spark is process. Hadoop MapReduce. Hadoop distributed file system is storage. Hadoop MapReduce is process. So data is stored in the disk, data in memory. Computing is based on the disk. Computing, everything in memory. So fault tolerance is done through replication. But here we can see RDD, okay, in upcoming sessions. So there is a fault tolerance through the RDD, not through the replication. So it is very easy and it is very reliable, and the data is available without replication. Okay, hard to work with real-time data, but easy to work with real-time data. Costly, less costly comparison to Spark because we are doing in memory. So RAM is obviously costly thing. Even how much you invented, how much you done, but it is little costlier than MapReduce. That should be actually for batch processing. Supports streaming and batch. Both can be supported by Spark. Supports interactive query. What is interactive query? Interactive query is nothing but streaming data. So streaming and as well as batch also supported by Spark. This is the main difference between MapReduce and Spark. Why we are going for the MapReduce? Especially, this is an interview question they will ask you. That's why I'm stressing this much. So MapReduce, we are doing disk to disk. But in Spark, we are doing in memory. That is only the difference. And it is only for batch processing. It is for streaming also. This is real time and it is real time. It's hard to work, but it is easy. What is real time data? Real time data is nothing but a streaming data only. Okay. So any queries you can ask. Let me know if you have any queries.
Divya, I mean, like for batch processing and that medallion architecture, what is the main difference?
That batch processing and
I mean, you mentioned medallion architecture, right?
um, so medallion architecture is nothing but you are storing data in layers. Okay, I'll give you that. Medallion architecture is a kind of architecture. You can see your bronze layer landing. You as you said, we are having landing layer, right?
Yeah.
Landing layer. So in the landing layer, what they will do is they will store the data in native format. Suppose if you are receiving through Excel, so in landing layer you will have the Excel file only. But in bronze, it is going to be converted. What is Parquet and don't get confused, I'll explain. So it will be moved into bronze layer in Parquet format. Here and next, when you are going to your silver layer, it is aggregated data or cleansed data. It would be there like deduplicated data and everything in the
Okay.
silver. And after silver layer, you are having gold. That is your consumption layer you call. Silver is the curated layer. In the consumption layer, you will have the fine data. It is used, it is in the usable state for the Power BI. When you are calling batch data can also be processed all these layers, in all these layers. Okay. So batch data is nothing but the data which is historical. You are having some amount of data that you are processing through all these layers. If you are having streaming data, that also can be processed through all these layers. That is one type of architecture where you are storing your data in layers form. Don't compare batch data
Yeah,
and
yeah.
medallion architecture. Medallion architecture is an architecture where you are storing your data in a kind of process you are doing that. Batch data is nothing but historical data. You will load this much data like that. Streaming
Yeah,
data, batch data, you need to compare. Streaming data is nothing but current data where you are getting through streaming.
yeah,
Batch data is nothing but you are already having in your Oracle DB or in your, you told, right? Somewhere you are getting through files.
yeah.
That is batch data. Whatever you are doing now, that is batch data.
Yeah, yeah.
Okay, fine.
Thanks.
Uh, thank you. Any queries? Aditya, you have any queries?
No, ma'am, got all the things clear. Thank you.
Oh, okay. Thank you. Tomorrow we can continue.